Since inception, poor scalability has plagued blockchain technology, forcing developers to continuously look for new techniques to scale their network as the crypto community continues to expand across the globe. One creative means developers have devised to improve their network's scalability is the Layer 2 or L2 blockchain solution. In this video, we will look at what L2 solutions are, their examples, as well as their importance. Layer 2 blockchain solutions are extrinsic protocols, not native to the main network, that divert part of main chain's transaction traffic off-chain, thereby freeing up some space in the database storage of the main network. They are often extensions built on pre-existing Layer 1 network to improve the efficiency and transaction fees of the base network. For context, Layer 1 protocols are the basic structure of a blockchain platform, usually called the mainnet or main chain. They are tasked with the function of validating on-chain transactions themselves, and also own a native token that they use for transaction fees. Typical examples of L1 are Ethereum and Bitcoin, which are generally governed by the blockchain trilemma rule. The rule lists three main core properties: decentralization, security, and scalability, which every blockchain can have, but of which a network can only process two. By default, scalability is often sacrificed out of the trio on most networks. For the stated reasons, blockchain data is relatively safe and secure on Ethereum and Bitcoin networks, which exhibit both security and decentralization properties, sacrificing scalability. However, they suffer poor transaction speed as they process 15 and 7 transactions per second, or TPS, respectively. These transaction rates are very slow compared with other payment platforms' throughput, like Visa, which processes 45,000 TPS. To hedge the scalability issues, L1 networks use strategies like sharding and changing the consensus models. But these methods cannot effectively solve the issue as the networks are still lagging. Hence, the need for a better and more efficient protocol that can scale networks and still retain the platform's decentralized and secured nature motivated developers to invent the Layer 2 solution protocols. These solutions are rooted in L1 mainnets and do not affect the intrinsic features which make the L1 secure and decentralized. L2 protocols act as secondary frameworks for processing transactions off the main chain and return the process data to the storage of the blockchain. Their function reduces the transaction traffic on the main chain, thereby scaling the number of transactions a network can execute per second, and also reduce the transaction fees on the network. Several L2 solutions exist, one of which is the state channels, which allow users to perform numerous off-chain transactions by just submitting 2 transactions to the main chain. State channels help to bypass the need for miners while minimizing the communication between L1 and L2. Another L2 solution is the nested blockchains, which allow L2 to carry out transactions while L1 validates and issues blocks. However, the most prominent of these L2 solutions is the roll-ups, which validates multiple transactions, rolls them up in batches, and then sends them to L1 for storage. So, will Layer 2 protocols produce faster and more cost-effective Layer 1 protocols? Stay tuned. Cheers.